All right, we are going to be solving absolute value inequalities. So the first thing we need to do is we need to look at how do we solve them? What are the steps? So the first thing I need to do is I am going to isolate the absolute value in the inequality. So what that means is I have my absolute value, whatever's inside of there is going to be greater than or less than some number. So if there's anything on the outside of that absolute value, I've got to move it to the other side. My next step is I'm going to split the inequality into the two cases. Remember when we did absolute value equations, we talked quite a bit about how there's a positive possibility and a negative case. There's a positive case and a negative case whenever dealing with an absolute value. So when we do an inequality, we're going to do the same thing, except for since it's an inequality, we have to be careful as to which connecting word we're going to make. We're going to turn that inequality into a compound inequality with either the or the and in there. So the way that we know the difference is if the absolute value is greater than a number, then you're going to write it with an or statement in it. If the absolute value is less than a number, then you're going to write it like an and statement. Now, here's the deal, something to kind of help you there. If you think about it, the word greater sounds like it has an or. Less than has that and sound to it. So you can kind of use that as a little help to make sure that you're getting the correct word. The second thing is when we introduce the negative case, what's going to happen is the inequality symbol has to flip on both cases. So whenever we do that on both, it's going to flip that and move those inequality pieces around. Okay, then once we have it set up, we are going to solve each inequality and graph just like we did with compound inequalities, paying close attention to the or and the and part of this. So we're going to start in on this first one and we look and we say, okay, my absolute value is isolated and it is a greater than symbol. Greater or symbol. So what we're going to do is we're going to split it and we're going to make it into an or statement. So x minus 7 is greater than 10 or x minus 7. Here's where we flip the inequality and we make the 10 the opposite, the negative of it. So we have our positive case and our negative case. Now when we go to solve, we're going to add 7 to both sides. So x is greater than 17. Or I'm going to add 7 to both sides here. X is less than negative 3. So now think about an or statement. I get to include everything from both graphs. So x is greater than 17 and x is less than negative 3. So that means I would have an open circle at 17. I'd have an open circle at negative 3. On the 17, I'd go to the right because x is greater. On the negative 3, I'd go to the left because x is less than that. And that's how we would do that absolute value inequality. Here, let's try this second one. So the first thing I check, my absolute value is isolated. The next thing I look at is it is an and statement. The reason I know it's an and statement is because it is a less than symbol. So what I'm going to do is I'm going to bring the number over. I'm going to make it into my negative case. I'm going to bring the inequality symbol over. Negative 9x less than 63. At that now, I'm going to come down. I'm going to divide by negative 9 to each of these. And I get 7. Now remember, when we divided everything by a negative number, that flips the inequality symbols. So 7 is greater than x, which is greater than negative 7. Now, remember, with an and statement, because that's what we're working with here, this is an and statement. Remember, we are looking for where are they overlapping. So if you read this first one here, it says 7 is greater than x. So that means that x is less than 7. The second one here says x is greater than negative 7. So it'd be an open and going to the right. then you ask yourself, where are they being shared? And it would be all that part in the middle. So we'd go -7 to 7, and we would shade the part in the middle there. And that would be the solution to that absolute value inequality. All right, let's try a couple more here. So we look, our absolute value is isolated. I look again, the symbol that I'm looking at is a greater than symbol. So now what I'm going to do is I'm going to set it up as an OR statement. So 1 plus 2x is greater than 1, or 1 plus 2x. Here's where we flip the symbol, make it a -1. Now we solve, so I'm going to -1 from both sides. So I get 2x is greater than 0. I'm going to divide by 2, so x is greater than 0. Or I'm going to -1. So 2x is less than -2. I'm going to divide that by 2. And x is less than -1. So I come in here, I have -1, 0, and 1. So when I look at this, the first one, it's an OR statement. And it says x is greater than 0. So it'd be an open circle at 0, and I'd shade to the right. Or x is less than -1. So an open circle at -1, shade to the left. And remember, in OR, I get to keep everything from both graphs. Those are both part of my solution set. Okay, let's take a look at the second one here. So I start here, and my absolute value is isolated. So the next thing I notice is it is a less than symbol. So I bring the 28 over. I make it my negative case. I include everything that is inside the absolute value. And then I bring down my 28. Now I go to solve this. So I'm going to add 4 to all three sides. So that's going to get me -24 is less than or equal to 6n, which is less than or equal to 32. At that now, I'm going to divide everything by 6. So -24 divided by 6 is -4, less than or equal to n, less than or equal to. Now, 32/6 as a fraction, the 32 cannot be divided evenly by 6, so we're going to leave it as a fraction, and we're just going to simplify it. We simplify it by dividing by that greatest common factor, which in this case would be a 2, and that would leave us with 16/3. Now, remember what we're dealing with here is we are dealing with an AND statement again. So when we look at this, the first one says -4 is less than or equal to n. So that means n must be greater than or equal to -4. And n is less than or equal to 16/3. So that means n is less than. And we're asking ourselves, since it's an AND, where is that shared? And it is shared between -4 and 16/3. And that would be our solution that we have. All right, now let's try a couple where we have to do some isolating, some movement to get the absolute value isolated. So the first thing I'm going to do is I notice that I have this 6 on the outside. So I am going to -6 from both sides. Now, when I do that, you'll notice that that leaves my absolute value by itself on one side. 34 minus 6 is 28. Now we're ready to split. So I notice it's a greater symbol. So I'm going to split it into an OR statement. So 2x minus 10 is greater than or equal to 28. Or 2x minus 10. Now we take the inequality symbol, we flip it, and we make it -28. At that now, we add 10 to both sides. And we get 2x is greater than or equal to 38. We divide by 2, so x is greater than or equal to 19. Or over here, we're going to add 10 to both sides. So 2x is less than or equal to -18. We're going to divide by 2. X is less than or equal to -9. So now we're ready to graph this. So we come down here. It is an or statement, remember. So that means we get everything from both graphs. So x is greater than or equal to 19. X is less than or equal to -9. So we graph our inequalities, and there would be our solution to this. Okay, let's try another one. So over here, once again, we need to do some isolating. We need to get that absolute value by itself. So you should recognize that it's -8 times that. So to undo that, we're going to divide by -8. That's going to leave our absolute value as 2 plus 7n. Now, be careful here because we divided both sides by a negative, which flips the inequality symbol and makes it a 9. Now, since it's a less than symbol, that means it's an and statement, is what we're going to be working with. So we break it out. So we go -9 is less than 2 plus 7n, which is less than 9. So now at this point, I'm going to minus 2 from all the sides. So that gets me -11 is less than 7n, less than 7. I'm going to divide by 7 to all of those. And that's going to give me -11/7 is less than n, less than 1. Now, when I look at that, remember, 7 doesn't go into 11 evenly, so I'm just going to leave it as an improper fraction. So now I come down here to graph it. So I have -11/7, I have 0, and I have 1. Now, if we read that, it says -11/7 is less than n, so that means n must be bigger than -11/7. The second one says n is less than 1, so that's an open circle at 1, and I'm less than that. So then you ask yourself, where are they shared? Where are they overlapping? And it is between -11/7 and 1. Okay? And that's what that looks like. Now, remember, we have to isolate the absolute value every single time first. Okay, so now let's try a couple of these where there's more than one thing outside, and we want to get rid of that. So I'm going to start here, and as I notice, I have this 5 on the outside, so I'm going to minus 5 from both sides. So that's going to give me -2, absolute value, -4k, plus 3, and then it's going to be greater than -22. My next step that I'm going to do is I'm now going to divide by -2. Now, that will cause that inequality to flip because we divided both sides by a negative, and it gives me that. Now, I see that it's isolated. My absolute value is completely by itself on this side, so now we're ready to do the split. It's a less than symbol, so I'm going to go -11 is less than -4k plus 3, which is less than 11. Now we're going to take that, and now we're going to solve that part. So I'm going to minus 3, I'm going to minus 3, I'm going to minus 3. So that's going to give me -14 is less than -4k, which is less than 8. At that point, I'm going to divide by -4. And that's going to give us, now, this is another one of those examples. We're dividing by a negative again. So that's going to flip the inequality symbols. And then we have 8 divided by -4, which is -2. I have k in the middle. Now over here, I have -14 divided by a -4, which is going to be a positive. But 4 doesn't go into 14 evenly, so I'm going to divide by 2. That's the greatest common factor. And that would leave me with 7/2. Okay, now we're ready to graph. Remember, this time, this is an and statement because of the flipping that happened when we divided both sides by negatives and stuff like that. So this is an and statement. So when I look at this, I have -2, 0, and 7/2. So the first one says 7/2 is greater than k. So that means k must be less than 7/2. The second one says k is greater than -2. So that means k is bigger, so it goes to the right. And then because it's an and statement, we're asking ourselves, where is it shared? Where is it overlapping? And when we look at that, that is the area it's overlapping between 2 and 7/2. Okay, let's take a look at this last one over here. So once again, we need to get the absolute value by itself. So the first thing I'm going to do is I am going to minus 8, and I would get 5, absolute value of 2x minus 2, and that is going to be greater than or equal to 110. Then I need to get rid of the 5, so I'm going to divide by 5. And that's going to give me absolute value of 2x minus 2 is greater than or equal to 22. Now when we look at this problem, this is an or statement because I have my absolute value greater than a number. So that's going to mean I go 2x minus 2 is greater than or equal to 22, or 2x minus 2 is less than or equal to negative 22 because we have to flip the inequality. Now we're going to solve this. We're going to add the 2 to both sides. So 2x is greater than or equal to 24. I'm going to divide by 2. So x is greater than or equal to 12. Or on the other side, I'm going to add 2 to both sides. And I would get 2x is less than or equal to negative 20. I'm then going to divide by 2. And x is less than or equal to 10. Now remember, this is an or statement. So that means I get to include both graphs. So negative 10, 0, and 12. The first one says x is greater than or equal to 12. So I'm going to do a closed circle at 12, shade to the right. The second one says x is less than or equal to negative 10. So it's going to be a closed circle at negative 10, shade to the left. And that's what that inequality is going to look like. Now, the last two examples I want to go over with you are what we would call special situations, things that can happen once in a while that we have to be on the lookout for. So the first thing I need to isolate, so I'm going to add 10, and that's going to get me negative 6, absolute value of 5x plus 8, and that's going to be greater than 42. The next thing I'm going to do is I'm going to get rid of the negative 6 by dividing. So that gives me absolute value of 5x plus 8. Because I divided by a negative, it's going to flip that, and that's going to make a negative 7. Now, when we go to split these, here's the thing. If you notice, I'm saying an absolute value is less than negative 7. So stop and think. Remember, an absolute value of x, right, cannot equal a negative number. So let me ask you a question then. Can an absolute value ever be less than a negative? Well, if you think less than a negative means it goes further negative. It goes further in the hole, further borrowed, that type of thing, in debt. So when you think of that, absolute value is always positive because it's a distance. So when we say the absolute value is less than negative 7, that is actually going to be a no solution because you cannot have an absolute value less than a negative. And that's where we would stop on that. Now, let's take a look at the other special case that can show up. So when I look at this problem, the first thing I'm going to do is I need to get rid of that 7. So I'm going to add 7 to both sides. So that gives me 2, absolute value of 4 minus 10k. And that is greater than negative 32. Then at that point, I'm going to divide by 2 to both sides. And I get absolute value of 4 minus 10k is greater than negative 16. Now, once again, let's just stop there for a second. This would give us an or statement. But if we stop and just literally think it through logically, remember we said an absolute value is always positive. So when I look at this inequality, what I'm asking is, when is an absolute value greater than negative 16? Well, if an absolute value is always positive, then it is always greater than negative 16. It is never smaller than a negative 16. It's never smaller or equal to any negative. It's always a positive. So this is where we would say it is all real numbers. And that would be our solution. Now, like I said, this is a special case. Doesn't happen all the time, but it is a special case on those. And that is how we solve absolute value inequalities.